In the 1950s, we had overhead projectors. In the 1990s, we had PowerPoint. In 2025, we have XRXL. I'm Kabir Batra, and I will be presenting our work from Purdue University. Large lectures with over 100 students have become unavoidable at universities, especially in popular majors such as computer science and engineering. Unfortunately, these large lectures are often reduced to an instructor monologue accompanied by slides projected at the front of the classroom. Students can't meaningfully interact with the instructor, with each other, or even with the content being presented. They lose interest and they disengage. There have been many attempts to address this through physically reconfigurable classrooms that can switch between lecture and group work modes. However, these require expensive specialized infrastructure like pivoting desks and retractable displays. To address these challenges of large lectures, we developed XRXL to showcase the potential to use extended reality in extra-large lectures. Here is our XRXL concept. As you can see, each student is wearing an XR headset and can see 3D visualizations immersively by moving their head. At the click of a button, the instructor can virtually reconfigure the classroom. No need for pivoting furniture and displays. Here, the classroom is partitioned into groups of 4 students. Only one group is shown. However, implementing XR technology at the scale of a large lecture presents several significant challenges. First, we need to make sure that as the number of students and headsets grows, the visualization stays stable and synced. Second, scaling the classroom size requires maintaining accurate tracking across large physical spaces. Third, headset cost remains a significant consideration, with prices ranging from $300 to $500 per student. Fourth, creating intuitive interfaces is critical, as we cannot assume students or instructors are experienced with XR. Fifth, the system must address physical comfort, cyber sickness prevention, and maintain robustness throughout an entire lecture period. Despite these challenges, I'm excited to share that we have successfully implemented and tested an XRXL prototype with 82 students, which to our knowledge is the largest deployment of a co-located XR application to date. Here are some frames from our deployment with 82 students. Let me show you the key features of XRXL by taking you through the video footage of our working prototype, recorded during our 82 student deployment. The system can virtually retract the classroom ceiling and walls to accommodate large-scale visualizations that extend beyond the physical boundaries of the classroom. During setup, we defined the classroom boundaries to enable these transformations. Next, an important design decision was to not ask the instructor to wear a headset. Instead, the instructor controls the immersive visualization from their laptop. The laptop 2D pointer is converted into a 3D laser pointer, showing the students where the instructor is pointing. You can see how the ceiling and wall retraction can be used as a 360-degree theater, allowing us to transport the entire class to different environments. The student's reaction shows clearly how this feature can be especially engaging. Here is a demonstration of the system automatically partitioning the classroom into small groups of 4 students. Each group gets their own visualization and interactive panel. Also, each group only sees their own content. Lastly, the instructor can provide virtual assistance to any group without leaving their desk, appearing as a video feed next to the group's panel. Here are some of our findings. For question 1, students greatly enjoyed seeing 3D visualizations, validating our core design choice of using XR. For question 2, when comparing traditional and 3D visualizations, students showed a mild preference towards 3D, suggesting that both types should be interleaved throughout the lectures. For question 3, students were overwhelmingly enthusiastic about turning the classroom into a 360-degree theater. For question 4, students were neutral regarding group communication ease, which connects to the headset visibility challenge. For question 5, a subsequent small study showed strong positive response to the virtual instructor assistant feature. For question 6, while headset comfort remains a challenge, students might get more used to it with routine classroom use. For question 7, students were neutral about not seeing each other's faces. For question 8, for first-time headset users, the learning curve for hand gestures was noticeable, though familiarity would likely increase over time. For question 9, the concern of distraction might be addressed by using a mix of immersive and conventional non-immersive visualization. For question 10, when asked about future use, students showed openness to including 3D visualization in their large lectures. For question 11, students strongly believed that immersive visualization could make large lectures less boring and more engaging, validating XRXL's primary goal. For question 12, students showed clear hesitation to invest in a modern consumer XR headset at the current price point. For question 13, regarding headset availability, students expressed a clear preference for institution-provided headsets over the personal purchase model. Here are our other key metrics. The system usability scale score initially fell between good and okay. After fixing the video streaming issues in a subsequent small study, the SUS score improved to 72.5, placing it comfortably above average and between good and excellent. For cyber sickness, measured through the Simulator Sickness Questionnaire, we saw consistently low scores across all categories. This is attributed to the high and constant frame rate of the pass-through background that anchors students into their physical space. Finally, looking at task load through NASA TLX, mental, physical, and time demands were low, showing that our simple interface design was effective and headset discomfort was more of an annoyance than a burden. The high performance score indicates students felt successful in their tasks, while low effort and frustration scores suggest that the system was easy to use. Overall, the very low task load score of 2.9 supports our hypothesis that XRXL requires little effort from users. XRXL represents a step towards making any classroom virtually reconfigurable while enabling scaling immersive visualization. Thank you for your attention.